Good morning, all of you. Welcome to C. Jendra Rank Zone. In the previous lecture, we have done questions we have done the topic that is called kinetic theory of gases as well as molecular speeds. Now, in this lecture, we are going to discuss about questions based on kinetic theory of gases, kinetic theory of gases, and also and molecular speeds, because these are not discussed in the previous lecture. So now I'm going to discuss all these questions based on kinetic energy and kinetic theory of gases and molecular speeds. So all these are very, very important. Please note down in your classworks each question and we'll solve each and every question. Now question number 1. So before going to question, let us write the important formulas based on this. So we have already seen that based on kinetic energy. So average kinetic energy is proportional to average kinetic energy is proportional to absolute temperature, and kinetic energy is proportional to not only temperature but also number of moles. Kinetic energy is proportional to number of moles as well as absolute temperature, and this is point number 1. Point number 2, and how to calculate kinetic energy for n moles of a gas. Kinetic energy is equal to 3 by 2 nRT, where n is called number of moles, R is called gas constant, T is called temperature, absolute temperature. Next, concept number 4, average kinetic energy is equal to average kinetic energy is equal to 3 by 2 kT, where K is called Boltzmann constant. Already we know Boltzmann constant. Next, fifth concept, molecular speeds. We have 3 molecular speeds. One is most probable speed, average speed, and RMS velocity. So first we write CRMS. CRMS velocity is equal to root of 3RT by M, where M is called molecular weight, R is called gas constant, T is called temperature. Point number 6, C most probable speed is equal to, that is C star, we can say it is equal to root of 2RT by M. 2RT by M. And last we have C most probable velocity and C average, that is C bar. C average velocity is equal to root of 8RT by pi M. Root of 8RT by pi into M. So based on these concepts, we are going to discuss questions now. So please listen to this class very carefully. All the models are important for entrance exams. And last, we have one more point, that is C star, that is C molecular most probable velocity is to C average, C bar is to C is equal to 1.1 is to 1.228 is to 1.224. These are relation between all the 3 velocities. So these are the 8 points, important points. Apart from this, we have postulates of kinetic theory of gases. So all these points are very important. So now we'll start questions based on this. Please listen carefully. Now question number 1. Question number 1. The kinetic energy sulfur dioxide gas is twice as heavy as oxygen gas. Hence, at 25 degrees C, at 25 degrees C, the ratio of average kinetic energies of average kinetic energies of sulfur dioxide and oxygen molecule is. They are asking ratio of average kinetic energies of sulfur dioxide and oxygen molecules. Option A, that is 1 is to 1. Option B, it is 2 is to 1. Option C, it is 1 is to 2. And option D, it is 4 is to 1. So this is a question. So please think about it and do it now first of all before I solve. So they are given sulfur dioxide. You know sulfur dioxide molecular weight is sulfur dioxide is equal to sulfur is 32, oxygen is 32 oxygen atoms. So it is equal to 64. That is the molecular weight of sulfur. Similarly, the molecular weight of oxygen gas is already we know it is 32. The molecular weight of oxygen gas. Now, sulfur dioxide is twice as heavy as oxygen gas, as it is correct only. Hence, at 25 degrees C, that is temperature is given 25 degrees C, the ratio of average kinetic energies of sulfur dioxide and oxygen molecules. This question is very, very important. This is based on concept. So, simple concept already we know. Since average kinetic energy is proportional to absolute temperature only. It is not proportional to molecular weight or number of moles. It is only depending on temperature. So since they are given at 25 degrees the same temperature, we can say average velocity is equal to average kinetic energy is in the ratio 1 is to 1, because since average kinetic energy is proportional to temperature only and it is independent of molecular weight, is not depending on molecular weight. It is not depending on molecular weight. So we can say it is 1 is to 1 ratio. Answer is first option. Very, very important, children. This question is very, very important. So please note it down. So wantedly, they have given correct statement. That is, first statement is true. What is that? Sulfur dioxide is twice as heavy as oxygen gas. Hence, at 25 degrees C, the ratio of average kinetic energies of these molecules, that is sulfur dioxide and oxygen molecule is. So that is 1 is to 1 only, even though sulfur dioxide weight is 64 and the molecular weight of oxygen is 32, but average kinetic energy is not depending on number of moles. It is depending only on absolute temperature, that is T. Hence it is called as, it is nothing but it is not depending on molecular weight. So answer is 1 is to 1, because the same temperature is same for both of them. The temperature is given as 25 degrees C only. I hope so. This is the answer. Next, question number 2. Question number 2. Let us discuss. Very, very important, all these questions. The ratio of kinetic energies of equal number of the ratio of kinetic energies of equal number of moles of hydrogen gas, moles of hydrogen gas and helium gas at the same temperature, at the same temperature is. Option A, it is 1 is to 2. Option B, it is 2 is to 1. Option C, it is 1 is to 1. And option D, it is 4 is to 1. So how to solve this problem? This is kinetic energy. They are given only kinetic energy, not average kinetic. Since kinetic energy is proportional to, kinetic energy is equal to 3 by 2 nRT. Means it is depending both on number of moles as well as temperature. So we can say kinetic energy is equal to 1 by kinetic energy 2 is equal to Kinetic energy 1 by kinetic energy 2 is equal to N1 T1 by N1 T by N2 T2 because they are given same temperature. So N1 by N2 T. So we know 1 mole of hydrogen is 1 mole of hydrogen gas is 2 and 1 mole of helium is 4 because molecular weight of helium is equal to 4 and because molecular weight of helium is equal to 4 and molecular weight of hydrogen gas is equal to 2. So the kinetic energy ratio of kinetic energies of number of moles of hydrogen. First is hydrogen, second is helium. So Ke1 by Ke2 is equal to this is 2 into T, that is number of moles. That's consider it is 1 mole. 1 mole means given weight by molecular weight. So 2 into T by and N2 is 4 into T. So T into T gets cancelled. So it is 1 by 2. So it is in the form of 1 is to 2. 1 by 2. So it is nothing but what? 1 is to 2. So answer is first option. So even though they have same temperatures, but since kinetic energy of equal number of moles they are given. So let us take 1 mole of hydrogen gas and 1 mole of helium gas. So 1 mole of hydrogen gas is weighing 2 grams and 1 mole of helium gas weighing 4 grams. Since already we know the molecular weight of helium is 4, molecular weight of hydrogen is equal to 2. That's why we have taken equal number. Equal number means 1 mole. So 2 by 4 into T into T. So the answer is 1 is to 2. So this is clear. Next question. So this is question number 2. Next question, question number 3. So these are based on concepts. Now, next question, simple direct question. They are going to calculate the kinetic energy of 28 grams of, or you can say, let us say, not 28. So calculate the kinetic energy of 88 grams of carbon dioxide gas, 88 grams of carbon dioxide gas molecules, kinetic energy of 88 grams of carbon dioxide at 27 degrees C in calories. When they are given in calories, very, very important. Why I want to discuss this question? When they are given in calories, we have to take, since already we know kinetic energy is equal to, for this I am not giving options since it is a numerical. So kinetic energy is equal to 3 by 2 into N into R into T. That is 3 by 2 nRT. And suppose if the kinetic energy is given in joules, we have to take R value is equal to, if the kinetic energy, if they ask in joules, they ask in joules or kilojoules, we can take R is equal to 8.314 joules per Kelvin per mole. Joules per Kelvin per mole inverse. Whereas if they are given kinetic energy, since they are given kinetic energy in calories, kinetic energy in calories, so we have to consider R is equal to 2. R is equal to how much? It is equal to approximately 1.97. So we will take it as 2. So by this we can say kinetic energy is equal to 3 by 2 into N, where N is called number of moles. How to find number of moles? So number of moles N is equal to, given weight is how much? 88 grams. 88 grams by carbon dioxide molecular weight is 44 grams. 44. So it is how much? It is 2 moles. So 3 by 2 into 2 into 2 into temperature 27 degrees C means 300 kelvins. So 3 by 2 into 2, that is, so 3 into 2, 600, 600 these are. So it is 1800 calories, 18,000. So 3 to the 6, 6 into 300. So it is approximately 18,000 calories. Or you can say 1.8 kilocalories. Because 300 into 6, 300 into 6 is 1800, only 1800. So 1800 means 1.08 kilocalories. So this is 1800 calories because 300 into 6 is 1800 calories. So we can say it is 1.08 kilocalories. I hope it is clear. So this is the question number 3, model number 3, very, very important. They'll ask for, especially for NEET, they'll ask in calories because it's very lengthy calculation in terms of joules. So especially they'll ask in calories. When they ask the kinetic energy of any gas in calories, very important to note that R you should take it as 2, that is calories Kelvin per mole. Calories per Kelvin per mole. the unit of R. So R value you have to take it in. R is equal to. Next, question number 5. Question number 4. The temperature at which methane molecules have the same average kinetic energy, have the same average kinetic energy as that of oxygen molecules, as that of oxygen molecules at 27 degrees C is at 27 degrees C is. So they are given the temperatures. So option 1 is 327 degrees C. Option 2, it is 27 degrees C. Option 3, that is C, it is 927 degrees C. And option D, it is 627 degrees C. Since we already know average kinetic energy is proportional to absolute temperature, so it is independent of number of moles. So number of moles, it is independent, means oxygen, whatever it is, oxygen or methane, both will have number of moles is not considered. So straight away we can say temperature. So average kinetic energy is proportional to temperature. So same temperature, that is 27 degrees C only, that is 300 kelvins only. The average kinetic energy of methane, and oxygen are equal. So average kinetic energy of methane and oxygen are equal. So we can say answer is 27 degrees C. Direct question. Because since average kinetic energy is proportional to absolute temperature, even they can ask 300 kelvins also. That is also right answer. So 300 kelvins are 27 degrees C. Because it is independent of molecular weights. Because average kinetic energy is depending only on absolute temperature. Whereas kinetic energy can depend on number of moles and absolute temperature. So this is question number 4. Next, question number 5. At 27 degrees C, the ratio of RMS velocities of oxygen, of ozone and oxygen molecule is option A, it is root 3 by 5, root of 3 by 5. Option B, it is root of 1 by 4. Option C, it is root of 4 by 3. And option D, it is root of 2 by 3. So very close options. But simple calculation, you should know the formula. Since already we know, since RMS velocity, that is C is equal to, of any gas, C is equal to root of 3RT by M. That is molecular weight. So for oxygen gas, we can say since R and T are constants, we can take. So implies, next step I'll write here. Implies C of ozone is equal to, that is RMS velocity of ozone is equal to root of 3 into RT, it is same, by molecular weight of ozone is, already we know ozone is O3 molecule. O3 means it is 48. So molecule of R is 48. That is also equal to root of 3 by 48. So this is RMS velocity of ozone. So it is 1 by 16. It is how many times? 1 by 16. So that is 1 by 1 into RT by 16. That is root of 1 by 16. So that is 1 by 16 root is 1 by 4. 1 by 4 into root RT. Because root of 1 by 16 is 1 by root 1 is 1 only and 16 root is 4. So 1 by 4 into root RT. This is RMS velocity of ozone. Similarly, we can find RMS velocity of oxygen gas. So RMS of velocity of oxygen gas is equal to root of 3RT by 32. 3RT by 32. So 3RT by 32, it is not dividing. So root of 3RT by 32. So that is equal to root of 3RT by 32. Simple, directly we'll write root 3 by 32 into R into T. So this we can write as root 3 into RT, root of 3RT, and root 32 can be taken as 2 into 16. So 2 into 16 or 4 into 8 we can take. So by substituting these two, we'll get the answer. So root RT gets cancelled. So 1 by 4 by root 3 by 32. 1 by 4 by root 3 by root 32. 1 by 4 divided by root 3 by root 32. So after simple calculation, you can solve this. And after simple calculation, you get the answer. So it could be 1 by, it could be root 3 by 3 or any of the options. So I'm giving this option, this answer you have to calculate. So 1 by 4 by root of root 3 by 32. So root 32 will come to numerator. So that is 1 by 4 into root 3 into root 32. So this you can calculate and you can find the answer. So this type of questions are important. So what is the question again I'm discussing here? At 27 degrees C, the ratio of RMS velocities of ozone and oxygen molecule is, since RMS velocity formula is root of 3RT by M, ozone molecular weight is, because R and T are constant. So because they have same temperature they are given, so 300 kelvins you can write, but no need of writing temperature because both will get cancelled. So oxygen ozone molecule is equal to 48. So we got 1 by 4 root of RT, and this RT gets cancelled because we divided by, if we take, so 1 by 4 by root 3 by root 32. So that is 1 into root 32 by 4 into root 3. If you calculate this, you will definitely get any of the option. Next question. Question number 6. The most probable velocity of the molecules. The most probable velocities of the molecules of gases, of the molecules of a gas is 1 kilometer per second. 1 kilometer per second. Continuation. The RMS velocity of the gas molecule is, the RMS velocity of the gas, same gas, the gas molecules of the gas is same gas. So option A, it is 1.128 kilometers per second. Option B, it is 1.224 kilometers per second. Option C, it is 1.5 kilometers per second. And option D, it is 1.086 kilometers per second. So they are given 4 options and they are given most probable velocity, and they are asking us to find RMS velocity of the same gas. Since already we know the relation between C star, that is most probable velocity, that is CMP, is to C average and C bar is to C, that is C RMS is equal to 1 is to 1.22, sorry, 1.128 is to 1.224. So they are in the ratio of 1 is to 1.224. So definitely the answer will be 1.224 kilometers per second, because they are asking most probable velocity and RMS velocity. So this relation is very important. So that's why this question has come. So most probable velocity, relation between most probable velocity and RMS velocity is equal to 1 is to 1.224. Since the RMS velocity, the most probable velocity of the gas molecule is given, most probable velocity of the gas molecule is given as 1 kilometer per second. Hence, its RMS velocity of the same gas will be 1.224 kilometers per second, and its average speed will be 1.228 kilometers per second. So answer is second option. Next question. Question number 7. The RMS velocity of carbon dioxide, the RMS velocity of carbon dioxide gas at a temperature T, absolute temperature T, is x centimeters per second. At what temperature? At what temperature the RMS velocity of carbon dioxide would be? The RMS velocity of carbon dioxide would be 4x. Would be 4x. So they're asking what temperature it will be 4x. So option A, it is 16T. Option B, it is 2T. Option C, it is 4T. And option D, it is 32T. So they're asking this question. The RMS velocity of carbon dioxide gas at a temperature T is x centimeters per second. At what temperature the RMS velocity of the carbon dioxide would be 4x? So let us take into consideration RMS velocity. C RMS is equal to root of 3RT by M, that is molecular weight of carbon dioxide. So we can say in the first case, that is C1 RMS is equal to x centimeters per second, which is also equal to root of 3 into R into T by M. Is first case. Second case, C2 RMS velocity for the same gas is equal to 4x. So 4x is equal to root of 3R. Temperature we have to find, that is, let us take it as temperature, we have to take it as P. Let us, because you have taken it as X. So now in this two cases we have to find P. What is P? So by this you can say X by 4x. So we can say X by 4x is equal to root of 3RT by M divided by root of 3RP by M. So by this you can say M gets cancelled, 3 gets cancels, R gets cancels. So we have only root of T by P. So X by 4x is equal to T by P. Implies P is equal to X, and X gets cancelled 1 by 4. So P is equal to, so X by 4, 1 by 4 is equal to T by P, implies P is equal to T into 4. So answer is 4T. Answer is how much? It is 4T. So is it clear? So this is called 4T is answer. Simply I have taken X by 4x, root of 3RT by M. Second temperature I have taken test. First temperature T. Second temperature, because first temperature they are given at T temperature would be, and second temperature I have taken it as P. So now they are asking at what temperature, that is P value they are asking us to find. So x by 4x is equal to root of 3RT by m into by divided by root of 3RT by m gets cancelled, 3R gets cancelled, and root gets cancelled. Only we have root of T by P is equal to, so this is very important, root of T by P is equal to 1 by 4. So implies root P is equal to 4T. See, root P is equal to 40. So P is equal to 2T. So answer is second option. It is not third option. It is second option because we have root also. Root gets cancelled. So root P is equal to 2T. So answer is 2T. Very, very important. Very, very important. This is previous JEE mains questions. So this is question number 7. So these are the important models of all the questions based on kinetic theory of gases, as well as kinetic energy, as well as average kinetic energy, and even molecular speeds. So all these 7 models are important. Definitely you are going to get based on these 7 models. Simple formula application, or they ask us to calculate the temperature, or they ask us to calculate the value also. So all these points are important. So with this, I'm stopping this lecture, because next lecture we are going to discuss based on real gas and ideal gases. Thank you all.